Hello guys, welcome back to Jyoti classes, and today we will be taking few more questions of CSIR NET. So let's start with our first question. The first question is asked in CSIR NET June, and the question states that the internal energy E of a system is given by E is equal to Bs cube by Vn, where B is the constant and the other symbols are their usual meaning. The temperature of the system is equal to, the options are given. Here E is mentioned, we know the formula TdS is equal to dE plus PdV. Then take the value for dE is equal to TdS minus PdV. At the constant volume, the internal energy with respect to entropy is known as the temperature. Then differentiate dE by with respect to S, where V becomes the constant, and we will get the value of temperature. Just do the partial differentiation of S of the given E value, that is E is equal to Bs cube by Vn. When you partial differentiate, it will become 3Bs square by Vn is equal to T. Okay, therefore the option number B is the right one. Now moving on to the next question, and the next question states that the number of atoms for two level system is 3 into 10 to the power of 18 and 0.7 into 10 to the power of 15 for the upper and the lower level respectively. If the energy density of the system is 9.0 joules per meter cube and the coefficient of stimulated emission is 3 into 10 to the power of 5 meter cube by Ws minus 3 minus, then what is the rate of stimulated emission? They are asking us to find the stimulated emission. We know the expression for stimulated emission is that B21 rho V or rho nu into N, where B2N is the Einstein coefficient for the stimulated emission, where rho V is the energy density and N is the number of atoms at the upper level. Then just substitute all those values which are mentioned there. That is, the rate of stimulated emission can be calculated as B12 already given, that is 3 into 10 to the power of 5, and 9 energy density is mentioned, that is 9.0, and next N, number of atoms in two level system is 3 into 10 to the power of 18. Just multiply all those and you will get the value as the rate of stimulated emission is 81 into 10 to the power of 23, 2 minus. Here I have not mentioned the options. So this is the answer for this question. Okay. Next, moving on to one more question, and the question states that the wave number of the emitted or absorbed radiation during a transition between two levels is, the transition between the two levels is 30.5 centimeter inverse, and the rotational constant for the transition is 1.89 centimeter inverse. The quantum state of the low level is, okay, we know the wave number for the corresponding transition, that is from J to J plus 1 in the rotational constant in the rotational spectra is nu is equal to, or V is equal to 2B into J plus 1. J plus, they are asking for the lower level, J plus 1 is equal to nu by 2B. 2B value is already mentioned. Just here 2B is equal to 1.89 centimeter, that is the rotational constant. Just take the rotational constant, mention nu, that is the transition between the two levels is 30.5 centimeter inverse. When you divide it, you will get the answer 16.13 by 16. Just J is equal to 15, and here nu is the wave number and B is the rotational constant. So option A is the correct one. Okay. Next, moving on to one more question, and this is asked in CSIR NET December 2014. Here this question is based on classical mechanics, that is time independent Lagrangian question. Here simply we have to find the equation of the motion for the given system. Okay, the question states that equation of the motion of the system described by the time independent Lagrangian. It is mentioned L is equal to E nu t 1 by 2 m dot square minus Vx. Just we know that what is the equation of motion for Lagrangian, that is d by dt into dou L by dou x dot minus dou L by dou x dot. Just take the values for dl dou L by dou x dot, dou L by dou x. You will get the respective values for both of that, and after that just put it in the given equation form and then further simplify. When you put those values, you will get as E nu t mx dot plus dou v by dou x into E nu t. When you again differentiate this with respect to t, you will get it as mx double dot, that is mx double dot e to the power of nu t plus mx dot nu, and dv by dx where e to the power of t is taken common, and when you take this e to the power of nu t into 0, the remaining equation remains this much. Okay, that is mx double dot nu mx dot plus nu v by x is equal to 0. Okay, that is option number A. Okay, now only these many questions for today's classes. If you have any doubt, if anything, if you don't get, just mention in the comment section. So thank you guys.